NASA finds a potential sign of ancient life on Mars, Stoke Space wraps up a crucial test with its fully reusable Nova rocket, Blue Origin makes progress towards turning moon dust into useful stuff, and SpaceX spends a fortune on Starlink direct-to-cell. As always, we'll have all that and more coming up this week in Spaceflight. This week we had a bunch of updates from a number of different rocket companies, so let's take a look at a few of them. We'll start off with Relativity, who released their monthly update on Terran R's development this week. A few key milestones have been passed since their last update in August, one of the more critical ones being the completion of Terran R's thrust structure. This structure will be the one that'll transfer the loads of all 13 Eon R engines to the rocket, so it has to endure the rigors of ascent. It'll also endure the forces of descent as Terran R's first stage comes through the atmosphere for a drone ship landing. Relativity says it recently completed the structural test stand outside their Long Beach factory in California, and they've already started the structural testing of this thrust section, simulating max Q conditions. The company has also completed all barrel sections for the first stage that'll be used on Terran R's first flight, and welding has already begun to put together the fuel tank of the booster. Relativity also completed manufacturing of the first Eon R engine for that first flight and will begin acceptance testing in the coming weeks. In last month's update, Relativity announced they'd completed manufacturing of the developmental Eon V engine, the engine that'll power Terran R's second stage. In this monthly update, the company has now shown footage of its testing, which included different mixture ratios, throttling, and gimbaling of the engine during operation. Relativity is also continuing to outfit the first stage test stand at Stennis with new commodity tanks. This is where, in the future, they'll test completed first stages while on the ground before being sent to the Cape for launch. Hopefully, we'll get to see that sooner rather than later, but it does seem like we're getting close with each of these updates. Blue Origin's space ambitions aren't only about visiting certain places like the Moon or Mars, but also staying there and utilizing any available resources. This is in part why the company has a program called Lunar Permanence. As part of this program, Blue has been developing several technologies to enable this permanence, including turning lunar regolith into useful materials using what the company calls Lunar Alchemist. This week, Blue announced that it had completed the critical design review of Blue Alchemist, passing into the next phase, which is actual demonstration in a simulated lunar environment next year. According to Blue, the Blue Alchemist system is capable of taking in regolith and separating the oxygen from it to use as a rocket propellant or for humans to breathe. Other materials like silicon can also be extracted through the system, which would allow for the manufacturing of critical technology such as solar cells right there on the Moon. Milestones like this are the kinds of things that more and more companies should be working on if, in the future, we want to see permanent bases on the Moon or Mars and even other destinations. Being able to use the materials that exist right there instead of having to carry around everything from Earth will probably be one of the next keys to humanity's presence in space. Blue isn't the only one heading to the Moon. In fact, other companies with landers with Blue in their name have already been there well before them. And yes, I'm referring to Firefly Aerospace and its Blue Ghost lander. This week, the company shared an update on preparations for the second Blue Ghost mission. That flight will also feature the company's Elytra Dark spacecraft, which will tug the lander out to lunar orbit. The company shared these pictures this week, showing the completion of the structure qualification models for the combined Blue Ghost and Elytra Dark stack. Next, the two of them will be tested at the company's structural test stand at their testing facility in Briggs, Texas, to prove that the structures were built to endure the rigors of flight. Blue Ghost's second mission will be the first attempt by a U.S. lander to land on the far side of the Moon. So Elytra won't just be there to work as a tug, but also will be critical for the success of the mission, as it'll work as a relay satellite between Blue Ghost and Earth. Here's hoping for a smooth test campaign ahead. Stoke Space is also continuing to progress with testing of its Nova rocket. This week, Stoke announced that it had completed qualification testing for the second stage of Nova. According to the update, the stage went through cryogenic operations, over 100 pressurization cycles automated by flight software, and it was subjected to axial and shear loads during this qualification testing. Stoke's Nova rocket is the only other rocket, aside from Starship, that is actively in development with the goal of full reusability. This second stage, built of stainless steel, will have a different strategy towards reusability than Starship, though. Instead of using silica tiles on the side of the vehicle, the second stage will re-enter engine first and use the remaining propellant on board for cooling and, much later, for its landing burn. Progressing through qualification testing means that Stoke has now verified that the second stage design is much more mature and ready for actual flight, which the company hopes to carry out next year. So it is actually a huge milestone, as Stoke put it in their update, but there's still a long way to go till we see that debut flight. So keep on going, and let's hope that all future testing continues to be just as successful. Here at NSF, we'll continue to follow along as usual, and of course, once they reach the pad, we'll also cover that first launch of Nova live. If you don't want to miss live stream coverage like that, or these weekly news updates, be sure to like and subscribe to our channel. It's free, and it trains the algorithm in all the right ways to let us grow and do even more cool stuff here at NSF. Now, all the rocket testing that we've covered so far on this episode is testing that will very likely lead to a flight in the future. But sometimes we get updates on rocket testing that may not actually see flight. And this one is about Launcher's E2 engine. This week, the company released another amazing video showing off a 201-second-long burn at its test site in Mojave. But you might know this company better as having been bought a few years ago by Vast, the space station company. Originally, Launcher had plans to build their own small-sat rocket using this E2 engine, which, despite the bluish and purple tones of its exhaust, runs on a mix of kerosene and oxygen. When Vast bought Launcher, the company ceased development of that rocket, but it fully developed its engine and started testing it shortly thereafter. Nearly 2 years into testing, Launcher has been looking for companies to buy the engine, which it touts as the Kerlox engine with the highest performance in the small launch class. Publicly, no company has announced that they're flying this engine on any of their rockets, despite it now being proven under several of these long burn tests. So it's kind of a pity that an engine practically ready for flight is just being relegated to the test stand. NASA just revealed that a peculiar leopard spot pattern on a Mars rock could have been caused by ancient life on the red planet. Now, we covered the rock last year when the Perseverance rover found it in a former river delta. Scientists were intrigued by the pattern back then, and now that they've thrown pretty much every instrument in Percy's toolkit at it, the story has become even more interesting. The leopard spots visually show lighter spots surrounded by a thin border of darker material. This is a distinct pattern of minerals arranged into what are known as reaction fronts, points of contact where chemical and physical reactions occur. What remains of these reactions are signatures of two different minerals that are iron-rich in nature. One, called vivianite, is a hydrated iron phosphate, while the other, called greigite, is an iron sulfide. Among the leopard spots, there are also some much smaller dots of darker material, which were nicknamed poppy seeds by the scientists. So what could have caused this distinct pattern? Well, on Earth, vivianite is often found within sediment, peat bogs, and decaying organic matter, while greigite can be produced by microbial life. Both of these minerals being found in the same place on Mars is a potential indicator that microbial life once lived there, and its excretions may have formed these patterns. Now, there is always the possibility that the source of the leopard pattern was not caused by a biological process, though. For instance, high sustained temperatures, acidic conditions, and binding of organic compounds can also cause these minerals to be generated with no life in sight. But the scientists who studied the rock sample are skeptical of these explanations. There's no evidence that the right conditions for those processes were met at the place and time where this rock was formed. Therefore, with the current data they have, they're actually leaning towards the possibility of ancient life. Now, of course, that doesn't confirm anything yet. Confirming signs of life from the past or present takes overwhelming evidence, and there's only so much evidence that can be obtained with a robot on our neighboring planet. Ideally, scientists would next get their hands on samples to study them with tools that are available here on Earth. NASA's been working on a Mars sample return mission, but the current administration is also trying to cancel it, which is a whole nother saga that we've covered in detail in previous episodes. During the press conference about the findings, acting NASA Administrator Sean Duffy dodged questions about a possible return mission and made no promises that it will ever happen. It's probably safe to say that someday scientists will get their hands on Mars samples, but the question now is just who will actually collect them. And with Percy's recent findings, that day is going to become a lot more exciting. Remember Percy's companion, that little helicopter Ingenuity? It was, of course, the first to perform a powered flight beyond Earth, but it won't be the last. In fact, NASA is making lots of progress towards the next one, Dragonfly. It's a nuclear-powered helicopter the size of a car destined to explore Saturn's moon Titan. Now, because it's so far away from the sun, Titan is a frigid world with a surface temperature as low as negative 185 degrees Celsius, and at those temperatures, its surface is a crust of rock-hard water ice covered in rivers and seas of liquid methane and ethane. But scientists believe that below that crust lurks an ocean of water, and where there's water, there might be life. Now, of course, Dragonfly won't be able to get through the ice and research those oceans directly, but it will certainly help scientists to get some better insights into what's going on in the depths below. Throughout its planned 3-year mission, the craft will fly through Titan's thick atmosphere and touch down at multiple locations to study the surface in more detail. And this week, NASA ticked off some important milestones in Dragonfly's development. First off, the agency tested the helicopter's rotors in a wind tunnel. Attached to a full-scale model of half of the spacecraft, the rotors were subjected to an atmosphere similar to that of Titan's so that teams could study the effects of vibrations and stress loads. Meanwhile, teams completed testing of the insulation that'll keep Dragonfly warm in Titan's glacial environment. Using a wind tunnel and a special chamber that simulates the conditions on Titan, they validated that the foam will keep its shape and be able to protect the spacecraft from the elements. Additionally, scientists and engineers completed a crucial part of Dragonfly's mass spectrometer instrument, as well as the radio that will help the spacecraft to stay in contact with us back home throughout its mission. What's more, contractor Lockheed Martin completed the heat shield that will protect Dragonfly on its arrival at Titan. With all the parts coming together, NASA plans to start integrating the spacecraft early next year, and everything is still on track for a launch on a Falcon Heavy in July of 2028. From then, the spacecraft will take 6 years to get to its destination. But we won't make you wait that long to learn more. Be sure to keep an eye out for a future episode of Intrepid Museum's Astro Live, where we'll be talking in depth about the Dragonfly mission with the team who built it. And now for some news about space stations, like the upcoming one from VAST. The company's been busy testing components for its forthcoming space station, Haven 1, which is a small single-module space station designed to launch atop of Falcon 9. While the company intends to use the station to verify its ability to build functioning space stations, Haven 1 will host some payloads and experiments. To that end, it's outfitted with 10 mid-deck locker equivalent payload slots, which are, as their name implies, compatible with the payload racks installed on the space shuttle's mid-deck, which have become a bit of a standard for space station equipment and experiments. The payloads are provided power through VAST's homegrown payload power modules, which the company recently tested by hooking them up to a refrigerator. Not just any fridge like the one in your kitchen, but a special space-grade design named Polar, made to fit inside the mid-deck locker. True to its name, it can be set to frigid temperatures from 10 degrees Celsius to as low as -95 degrees. Polar is used on the International Space Station to preserve science samples, and it's regularly installed on visiting vehicles that carry cooled cargo. It's also been part of all Crew Dragon missions since Demo 2, but VAST specifically used it to test its power delivery hardware, demonstrating that the power module is up to NASA's standards and ensuring that the module is compatible with the requirements of VAST's payload partners. Recently, VAST also tested Haven 1's fans. These will of course be used to circulate fresh air around the station, and they'll also help to cool the payloads. Haven 1 is scheduled to launch no earlier than May 1st, 2026. Before then, the company plans to launch the Haven Demo mission, which is a small satellite to test the station's propulsion, avionics, and software systems, among other things. Haven Demo is set to hitch a ride to orbit on a SpaceX rideshare mission later this year. We also got a bit of news from Starlab this week, which is a collaboration led by Voyager to build a commercial research station. Like Haven 1, Starlab is designed to launch all at once, but it's much bigger. It's supposed to launch on Starship, and its 8-meter diameter gives it an internal volume of 40% of the ISS. Starlab can host up to 8 crew members and accommodate a crew of 4 continuously. The station's laboratory can host a total of 130 mid-deck locker equivalent payloads, and there's even some capacity to mount experiments outdoors on the station's exterior. This week, Starlab announced that it had finished a high-fidelity mockup. Apparently, it'll soon come to Building 9 at NASA's Johnson Space Center, which is home to the agency's space vehicle mockup facility. As the name suggests, that's where NASA keeps its vehicle mockups, including a full-scale model of the ISS. Astronauts use the facility to train in preparation for their missions. It seems that Starlab is now ready to test its mock-up there, most likely to simulate procedures to see what it's like to work inside of the station. This version will have gravity, of course, but it will nonetheless be useful to iron out some kinks before the design makes it up to space. Both Starlab and VAST want their stations to become a commercial successor to the International Space Station, though VAST has pitched Haven 2 for that, which is an evolution of the Haven 1 design, consisting of multiple modules. NASA's looking to replace the aging ISS as it's set to be decommissioned in 2030. To find a suitable replacement, the agency launched its Commercial Low Earth Orbit Development Program, also known as CLD. This program was established to guarantee continued human presence in low Earth orbit after the ISS meets its end. One of Sean Duffy's first acts as acting NASA administrator was to shake up this program by changing the rules. We covered this a few weeks ago, but if you missed it, he essentially relaxed the requirements and moved some important design and certification steps to future phases. Additionally, the new rules only promise full payment once the station actually hosts a crew of 4 in space for 30 days. NASA has now ushered in the next phase of the program by asking its industry partners for input on the new rules. Importantly, it's not looking for proposals just yet, only for feedback. It'll be interesting to see the response, as Duffy's changes seem tailored to newcomer Vast, and it would also mean quite a shift for the companies that have been working on the program for a while. Regardless, the clock is ticking. The deadline is only 5 years away, and that's not much time in the space industry. The new rules might help to speed up the process, but they also might be too little too late. Hopefully, the industry will come up with some solid plans once NASA is ready to receive proposals. Let's shift our focus to some other stories across space, starting with Chinese company LandSpace, which has recently hot-fired a full-flow staged combustion cycle engine. With this test, LandSpace joins a select group of companies that have fired up an engine using this particularly challenging cycle. Most famously, SpaceX's Raptor runs the same cycle and has been the only one to successfully fly so far. LandSpace confirmed the test on WeChat. Unfortunately, they only shared a blurry picture of the firing engine, so we don't know how long the test lasted. The engine is most likely the company's BF-20 engine, which, like Raptor, is powered by liquid methane and liquid oxygen, and boasts similar performance. Reportedly, the company's planning to use the engine on an upcoming launch vehicle with a 10-meter diameter, which would have 2 reusable stages. While that vehicle is at least a few years away, LandSpace might be very close to launching the maiden flight of its Juche 3 rocket. Not only is this the company's largest rocket to date, it's also methane-fueled and designed with a reusable first stage. Allegedly, the company is still planning to launch it before the end of the month, and the flight hardware might be heading to the Zhochuan Satellite Launch Center at this very moment. We'll definitely cover it whenever it goes up, so tune in to future episodes to see whether LandSpace manages to pull it off. Spanish rocket company PLD Space is making further progress on its Miura 5 rocket. Following updates in recent weeks about engine manufacturing and testing, this week PLD Space announced that it had completed structural testing of the rocket's interstage at the company's test site in Teruel, Spain. PLD says it subjected the interstage composite structure to different loads, including those expected during flight, including the maximum operating loads. The update also includes a reference to final burst, which means the structure was also tested to destruction, likely to find out its limits. The company says the interstage behaved as expected, so that means it's another thing that they can tick off the list of the many components of the Miura 5 rocket. PLD still seems committed to a debut flight of the rocket in 2026, so we'll see if future testing goes just as well. This week, SpaceX spent quite a lot of money on spectrum rights from EchoStar for its Starlink direct-to-cell service. In total, the company is spending $17 billion. 8.5 of that will be in cash, and the rest will be in SpaceX stock. This is the most money that SpaceX has ever spent in a single deal, and it's equivalent to about 75% of NASA's annual budget. It's also probably as much, if not more, money than what SpaceX has spent on Starship so far. And having these spectrum rights is a pretty big deal, because this now allows SpaceX to legally use the 50 megahertz spectrum that EchoStar had rights to until just a few days ago. EchoStar had plans to use this spectrum in the future, but following this deal, they've obviously dropped those plans. SpaceX will now use this for its next-generation Starlink direct-to-cell satellites that'll be launched using the company's own Starship rocket. With larger satellites and a different spectrum, SpaceX believes that it'll be able to operate at 20 times the throughput of the previous satellites and with a constellation with 100 times the capacity of the current generation. This shows that SpaceX is no longer a rocket company launching satellites and selling internet service. Rather, they're now a satellite company with rockets as a side hobby. And that's because the big money has always been, and continues to be, in the satellite business. Amazon is making progress with its replacement for NASA's TDRS network. Okay, there's a lot to unpack there, so in a nutshell, NASA is looking to replace its Tracking and Data Relay Satellite System, or TDRS for short. For decades, TDRS has been the agency's main way of communicating with pretty much any US satellite in low Earth orbit, including Hubble, the ISS, and commercial crew missions. But the system is getting old, so last year, NASA announced that it wouldn't allow any new missions to join the network. The agency is now looking for commercial partners to replace TDRS. NASA wants to become one of many customers of a commercial space communications solution, and there are multiple companies in the running to provide this solution, including Viasat, SpaceX, Inmarsat, and, well, Amazon. Or specifically, the government branch of its satellite internet provider, Kuiper. Amazon is working on a satellite to test its network for this purpose, which it plans to launch next year on a Falcon 9 rideshare mission. This week, the company filed with the FCC for that satellite, which makes a lot of sense. I mean, launching a satellite for testing communications without permission to communicate would be kind of silly, wouldn't it? This is your weekly space traffic report provided by Next Spaceflight. This week was quite an active one from China, which hosted 3 different launches. 2 of them launched additional satellites for the Yaogan series of secretive military satellites, which are often used for reconnaissance and technology testing. One of those was the Yaogan 45 satellite, which was rather interesting because, unlike the others, it was launched into a medium Earth orbit. Except for one mission, all prior Yaogan satellites have been launched into a low Earth orbit. So this one going to a medium Earth orbit means that one of these things is not like the others. The third launched from the Dongfang Hong Tiangong barge, carrying a batch of Geely navigation satellites for Chinese car manufacturer Geely. SpaceX also launched a series of Falcon 9 missions this week, including another batch of 24 Starlink V2 mini satellites from Vandenberg. Just a few days later, from that same pad, another Falcon 9 launched the first in a series of upcoming launches as part of the Proliferated Warfighter Space Architecture by the U.S. Space Force's Space Development Agency, often known as SDA. The architecture consists of different types of satellite constellations under what are called layers, which are launched in groups of different satellite generations called tranches. This mission in particular launched the first 21 satellites as part of the transport layer constellation of the Tranche 1 generation of satellites. The transport layer consists of high-bandwidth, low-latency communication satellites to be used by the U.S. military for communications. The companies selected to build these satellites were York Space Systems, Northrop Grumman, and Lockheed Martin, with the first 21 satellites provided by York Space Systems. Tranche 1 will also have a tracking layer, which will consist of satellites dedicated to missile detection and tracking, with Northrop Grumman and L3 Harris tasked with their construction. The SDA says that it intends to continue launching these missions on a monthly basis for the next 9 months until all satellites are fully up in orbit. This week we also had the launch of the Progress MS-32 spacecraft, carrying cargo and supplies to the International Space Station. Liftoff took place on September 11th at 1554 UTC from Baikonur, and Progress is expected to dock to the aft docking port of the station this Saturday at 1727 UTC. And right at the end of the week, after many weather-related delays, we had the launch of another Falcon 9 from Florida, carrying the Indonesian communications Nusantara 5 to a geosynchronous transfer orbit. The satellite, built by Boeing for Pacific Satellite Nusantara, also known as PSN, will now join other Indonesian communications satellites from PSN, such as Satria or Nusantara Satu. Going into next week, we have another Soyuz launch on the schedule, this one carrying a GLONASS global navigation system into medium Earth orbit. Next week, we also expect a few launches of SpaceX's Falcon 9, with potentially up to 3 of them being Starlink launches. One of them will be carrying the Northrop Grumman Cygnus NG-23 mission to the International Space Station. This will be the first flight of the extended Cygnus spacecraft, which Northrop dubs as Cygnus XL. This Cygnus carries an extra barrel section on its pressurized container, allowing a 33% increase in pressurized volume and cargo capacity, meaning it can carry up to 5 metric tons to the ISS. This will also be the third flight of Cygnus on a Falcon 9 rocket, and despite the extra cargo mass, Falcon 9 will still have enough performance to return its booster back to the Cape. So that means if you're in the area, expect to hear some rocking sonic booms. As of writing, the NG-23 launch is scheduled to take place on September 14th at 2211 UTC. But given the delays of the Nusantara 5 mission from the same pad, it wouldn't be surprising if NG-23 might move a few days to the right. But as always, you can stay up to date with all of that by going to the Next Spaceflight website or downloading the app on your phone to have it everywhere that you go. There might also be a Chinese launch or two sneaking into the schedule, so you'll probably see those pop up in Next Spaceflight in the coming days as well. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.